Good, good morning, students. I am Dr.R.Suganya, Department of Computer Science with Cybersecurity. Today we are going to see about the secrecy in the age of infinite computing. So, an educational deep dive into information theoretic security. The role of feedback loops in communication is like it moving beyond the computational complexity to achieve unbreakable security using physical layer properties. Okay, so here the thing is, the main thing is secrecy. Okay, so security beyond computational repeat. So how we can do that is very secured, and how we can guarantee that with power and time. So the guarantee safety against adversaries with unlimited computational power, unlike traditional RSA or ECC. It's also pioneered by Claude Shannon and later formalized by Wyner through the wiretap channel model. Okay, so and also it requires specific channel characteristics to perfect secrecy in practice. Okay, so that is what is. So infinite computing power is a traditional system. So quantum computing is already a game changer, we know, in this nowadays. And now about mapping the Alice Bob Eve dynamic. So here what is the thing is, the legitimate sender will be Alice and the receiver will be Bob, and the eavesdropper and main channel. Legitimate sender, that is Alice, is a party that wants to send a secure message to the intended recipient. She uses encryptions to protect the data, so only the legitimate receiver can decode it. Legitimate receiver Bob is the intended destination who receives encrypted signal, and its goal is to decode the message with zero error, assuming he has a power of decrypting the key. And what about the eavesdropper is trying to intercept and decode the communication between the Alice and Bob. And the main channel of this is Alice and Bob, where security is established through cryptographic protocols, ensuring the message remains confidential and integrity is protected. Okay. So when perfect secrecy hits zero, so when worst case scenario is zero and security danger, which is 100%, it is a slide suggests that risk can be effectively become zero when the worst case scenario is zero, implying full mitigation of risk. So the thing is, the application of the concept of perfect security in the information security. So it has to be transmitted with zero leakage to the sender. Okay. Next, harvesting keys from noisy channels. Okay, so secret key generation and coding strategies. Okay, so what is the thing is, here we should have the secret key generation, that is zero capacity channels into positive secrecy rates, and coding strategies like Scalvik, Kyla to Gaussian channels, and stochastic encoding to maximize the eavesdropper equivocation. Okay, and also next is about feedback as a security multiplier. Okay, so the thing is, here it compares the secrecy rates and communication channels with and without feedback. How feedback restores a capacity in challenging the channels. Okay, so channel type is three types of communication channels are listed, like degraded wiretap and modulo additive AVGN channel, that is Gaussian noisy channel, and without feedback. Okay, and also with feedback. So feedback in these channel enhances secrecy or transmission capacity, especially in secure communication system where eavesdroppings or noise is a concern. Okay, architectural patterns for feedback. So forward link, cooperative adaptation, and feedback channel. So here there is some forward link, cooperative adaptation, that is a feedback derived CSI, and the Bob to Alice return path, which may be public, private, or noiseless or noisy. Okay. And next is about quantifying in the feedback advantage. So without feedback and with feedback, with the channel type like degraded wiretap, model additive, AVGN channel. Okay, so positive rate, full capacity, and matches secret, it is lower rate. Okay, and next is about SWOT. strengths, weakness, opportunities, threats. So strength is like what is a strength here is like it restores secrecy in zero capacity channels. Weakness is it increased protocol complexity. So bandwidth for feedback this should be high for computational cost. Opportunity is like application 6G and secures IoT network and it resilience against quantum computing threats. And threats also it is eaves monitoring. Okay, so these are the things for SWAT. So the future of unbreakable links, feedback assisted information, theoretic security is a key to future-proof communication system. By leveraging that we can build system that remains secure against any level of adversarial computing power. Okay, thank you.